We will see about this method of cutting a CNC machine called CLcam. CLcam stands for Common Line Cutting Method. So this is basically a method of sequence or a toolpath cutting sequence, which will save a lot of cutting time on a CNC machine. It will also save a lot of material wastage by increasing the nesting efficiency. So that is the CLcam, common line cutting method. So let's see how it works. Let's say you have to cut a simple rectangle A, B, C, D. So the traditional tool path is like we travel from A, B, C, D, A. So A, B, C, D, A will be the traditional tool path. Now what happens in common line is we want to cut two pieces of this. So we make the line AB common for the two parts. So now for example, the tool path can be with a common line A, B, C, D, E, F, B. So A, B, C, D, E, F, B. So there are two options. You can either cut like that, where you cut the common line first, or there's one more path where you can go A, B, C, D, A, E, F, B. A, D, C, B, A, E, F, B. So in this, you are cutting the common line not at the start, but at somewhere in the middle, and then you are cutting. So each has its own advantages that we will see later. So this is basically, in essence, what is common line cutting. So for example, if you think of this as a 100 by 100 square, then here you are cutting, the tool has to travel about 400 mm, whereas here the tool is traveling only 700 mm for two parts. So it's not 800 mm. So that's about 12.5% reduction in the cutting time. So if this will take 8 minutes to cut, this will take only 7 minutes to cut. It's about 12.5% savings. So that is saving number one is in the cutting time taken will be less. And the other one is the nesting efficiency. For example, if you arrange parts like individual parts like this for cutting, you need to maintain a gap G1 between each part. And when you do that, for example, for each part, we are giving a gap. So you can only have 1, 2, 3, 4, 5 parts. Whereas here you can see that we have made common line. So this gap G1 here is 0. Here it's the same G1, but the gap G1 here becomes 0. So which allows you to do the nesting, and you can have extra more parts you can arrange. For example, here you can see there are 6 parts, whereas here there are only 5 parts if you are cutting without CLcam. CLcam, the method, you need a software which will automatically generate this toolpath, because all the geometries that you will be cutting won't be so simple like the square. So we'll be seeing how the CLcam software can be used at the end of this video. The software in general should also support the inner geometries, mirroring of the inner geometries. So if you want to cut like this, first it should cut the inner, this inner, then it should cut the outer. So that is one thing the software should have. Second thing is the tool offset. So it should be offsetting the inner geometries inside, and then the common line should be created, path should be created after offset is done on the outer geometry. That is the original geometry, you created the offsetted geometry. On that, you apply the common line method. So that we will see an example. Let's see how this is a MultiCNC software where you can do this common line cutting. So let's see how it works for a simple rectangle. So I can have an inner part also. I'm taking a 100 by 100 rectangle with a 50 by 50 inner rectangle. And I'm giving get G code. Okay. So I don't need that. And then here there is an option for generate CLcam. The other options you can retain the default options. And here I need to give my tool diameter. So I'm giving as 3 mm here, and I'm checking this generate CLcam option. So now when I give OK, so you can see that there is a dashed line that is being shown. That will be you need to select which line you want to be the common line.
whether it's this line, this line, this line, and things like that. So for example, if I choose 5, it will be this line. If I choose 9, it will be the top line, and so on. So let's take this as the common line. And there are some options like mirror and rotate, which we'll see later. We can do an arraying also. Right now, I will remove that. So if I give an OK, I get a toolpath, which I can save. This cutting path. So now the toolpath has been generated with this line as the common line. So you can do a simulation. You can see that it will. I'll do a simulation. You can see that it will first do the inner of this geometry first, then it will do this inner, then it will do finally the outer common line path. So it's cutting the second inner, and then finally it is cutting the outer. So now the common line was cut, and then it is cutting the outer. So that's how the command line works in this MultiCNC software. You saw that there are other options like there is a mirror, rotate option, and so on. So let's see where that is used. For example, if you take a shape like this, you can generate the command line by mirroring or by rotating. So let's see how it works. So let me show you how the command line works. So if you take this geometry and if I give the mirror command, then I can choose, I have to choose the object. So this is my object. Now select the first point of mirror line and the second point of the mirror line. So this is what you get when you do mirroring. It's not very compact. So in this scenario, mirroring is not so good. Instead, rotate option gives you a better nesting efficiency. So for rotating, it's always the middle point of the common line that you want should be selected as the rotation, origin of rotation. And I want to make a copy. So I give that, and then I give 180 degrees. So here you can see that rotate option has given you a much more compact output geometry compared to the mirror option. So this is mirror and this is rotate. So when you do subsequent nesting, you can get a compact nesting like this. Whereas if you had chosen the mirror option, you will get a not so compact nesting. But that's not always the case. There are scenarios where rotate will give you, mirror will give you better nesting than rotate. So this is an example shape where if you do mirroring, you will get this, and if you do rotate, you will get this. So you can see that the nesting is more compact in the mirror case compared to the rotate case. So depending on your geometry, you can choose whether you want to do mirroring or rotating. So one more thing you need to see is you will notice that there is a line filter length. So what happens is first the geometry, outer geometry is offset, and then only we choose which is the common line. So the problem when you do offset is that you get this small tiny line, you get a radius because of the offset you have done at the corners, and you can see that there are these tiny lines. Normally you would want common line to be one of these longer lines, but in between there are these tiny small lines which you don't want. For example, if you do if you actually choose one of them to be the common line, then you will get an output something like this, which is not really what we want. So the filter length will ensure that the list here shows only the bigger line segments. For example, if I go and make this in 0.1, then this list will be large. It will show so many small edges, because 1 is your big edge, and then you have 2, 3, and 4, which are tiny, and then 5 is your next big edge. Then you have 6, 7, and 8, which are tiny, and then you have 9. So you don't want that. That's what this line filter does. So we recommend that you keep it at 0.5 at 5 mm. Now you have only these 4 options, and you can choose how to mirror. And I can also do arraying. So for example, I will let's say I choose 9 as my common line, and I want 5 columns and 2 rows. Okay, then I can give an okay. Mirror or rotate doesn't matter in this case. So I do okay. And this is the output what you get. So you can save it if you want. And you can do a simulation, and you can see that it will do the inner first, then the next inner, then finally the common line. Finally the outer path, which has a common line. Okay, so you can do a faster simulation. You can see that it's doing all the inners first, then the outer, and then so for example, now this is 100 by 100 square, and we have cut 10 and total 20 pieces, right? So out of that, normally the cutting length for the outer, if you calculate, it would have been 20 times 400 mm. Now we saved about, in each pair, we have saved 100 mm. So 1, 2, 3, 4, 5. So we have saved about 1 meter of cutting length because we did this common line cutting. So that's an example. Now you can do it for more complex cases. For example, like an import a DXF. Let's take this DXF. And I can, so I'm choosing the common line, and I'm giving a tool radius, tool diameter of 3 mm. And when I give okay, so this is my part. So this I can choose to do the common line array. I can decide I'll just do a simple 2 by 2 array, mirror or rotate. You will see that all the inners also get correspondingly mirrored, and then the final geometry is generated. So when I give okay, so all the inners also got mirrored, and then this line, the common length is about 150 mm. So in this case, we saved about 600 mm of cutting length because this line has become common. So if I do a simulation, it will do all the inners first, then it will do the outer, which is the common line path. Right. So there are a few more shapes that you can try. So if I give okay. So even complex shapes, you can do the command line. So if you want to see the other options in command line, We have seen the line filter length, line index. You can choose mirror or rotate. You can choose CL first or CL not first. You can do arraying. You can also do a lead-in. Lead-in will add a small line as it enters this. So it's useful in certain scenarios. Okay, thank you.